All right, so we're going to look at a line class and client. And to do this, you're going to need to have the point class already coded. So that was, you can either get it from the PowerPoint or the previous set of videos. The line class will consist of two private point fields. So P1, we'll call them P1 and P2, and we're going to set up two constructors, one that accepts both points and the other that accepts a single sort of non-origin point with the assumption that the line passing through, that line will then pass through the point given and the origin. And then we'll do setters and getters for both those fields, the points, P1 and P2. And maybe we'll set up a find slope method that returns the slope, the double of the line through the 2 points. And double dot, not a number for an undefined slope. We did that from the calculator problem, so I'm just going to steal that syntax. And then we could have a couple of other sort of methods. Is vertical returns true if the line is vertical. Is horizontal returns true if the line is horizontal. Find equation returns a string equation of the line in the form y equals mx plus b with m and b both rounded to 2 decimal places, or x equals a for vertical lines. A two-string method. So the initial string representation would just be the 2 points, and then we could also add in, if we wanted, the y equals mx plus b form of the line. So there's some issues with lines. You know, what do we do if the person enters the same 2 points on the line, or if they change 1 point to equal the other point? You know, you need 2 distinct points to determine a line. So what if they end up sending 2 points that are the same? So there's some questions there, and I might just skirt around them for now. There are things that we could fix, but they might be more involved than I want to get into here. The other question that sort of is awkward is vertical lines, and you know, you don't want to divide by 0. So that's that double dot, not a number. But then if it's a vertical line, how do you represent the equation of that line? Also, because our points represent pixels, they're integers, and then if we have a double slope and y-intercept, potentially there could be issues. Not really, but there's issues around the whole my slope and my y-intercept are going to be doubles, and then potentially the slope is undefined. So how do you handle that? And how do you handle if, you know, 2 points are the same point? Because that would not define a line. But maybe we won't worry about those yet. We'll have an equals method that returns true if the 2 points stored in the line are equal. And again, we could sort of, what if we wanted, you know, the m and the b to be equal? Would that actually would be the same line, but it might not be the same line object that we're defining. So that's a question, and maybe it's a question that we may or may not resolve. An is parallel function that accepts another line and returns true if the 2 lines have the same slope. So that would also return true if you're saying is parallel to itself, which technically 2 lines that are the same line, we don't call them parallel. We say it's the same line. So that, again, mathematically, there's kind of an issue there, but we'll just say that it returns true if the 2 lines have the same slope, and we could build in code that eliminated or dealt with the option of what if they are the same line. And then is perpendicular will return true if the 2 lines are perpendicular. So we're not going to do all this in one video. Probably the first video we'll set up the constructors and the getters and setters. So, and we'll establish a client. So maybe not even the getters or the setters. Maybe we'll just do the getters. And we need the getters so that we can print these things. So and that's how we test it. So if we can't have the getters, we can't print it and we can't test it. And that's where the testing client comes in. Okay, so we'll go over to Eclipse. And I'm going to close all this stuff. Oh, I need that. I'll keep the point open. But I'm going to make two classes while I'm here. So I'm going to do in chapter 8 a new class called line, and just public, no public static void main, just finish. And we'll do a second class right now called line client. And again, you know, the clients, we've been, so here I do need main, public static void main, so I'll keep main there. But we've been using clients the whole time. Anything that uses an object is technically a client, but we're not calling them clients. Here I'm just using the word client because all it's doing really is testing, did it work? In your final project, you're gonna have like, you're gonna use a client or clients as you build your code, but then you'll build a separate client to show me the testing. So, you know, as you build is one thing, and then to demonstrate that everything works is another thing. Okay, so let's go to our line object, public class line. I could put some comments at the top. As usual, my name, my class, the date. You know, I don't really need to talk about what the object is unless it's, you know, more complicated. It's going to be clear from the fields here that I define, but you could say, you know, a line object defined by 2 points, by 2-point objects. So the line will contain 2 private fields, and they're both going to be of type point. So we'll call the first one P1 and the second one P2. So that establishes our fields, and then I want to have my constructor, which is just public, no void, no static, so public line, and I need the parameters. It's going to have a point, let's call it P1, and another point, call it P2. So notice the constructor is different in that, you know, there's no keywords in here except public, and that's what's, and then it has the same name as the class. So the capital line, all the other methods that we write always have lowercase start values. So the constructors have the same name as the class, and so it's going to be uppercase because classes are uppercase. So that helps us identify, you know, where the constructors are. So, you know, I could put that comment in there, constructor accepting 2 points. Constructor accepts 2 points. Let's say 2 will be specific point objects. So, and then because I'm using P1 and P2 again, I need to say this dot P1 equals P1, and you can see the highlighting that happens. See, the blue is highlighting back up to the blue, but this one is purple. And same thing again, this dot P2 equals P2. And now we want to go to our client and see that we can establish, create a new line. Now, you're going to need the point code to be in this default package with you, or you're going to get errors. Or, I mean, I guess you might not, because if you import java.awt, it has a point object already, but preferably we're just using our methods that we've created. And you could just use Java's, but then we're not learning. Okay. So this is a testing class. So I'm going to put my name in here. Testing client to build line object, or line class, actually. Again, the class is the abstract thing, and then the individual objects we're going to create here in the client. Okay, so before we can create a line, we have to create 2 points. So point P1 equals new point, and we'll just enter in, say, 5, 8, colon there, and point P2 equals new point O. So let's pick a point so that we know, what the slope will be. So let's go with 6, 9. That'll have a slope of 1. It went 1 to the right and 1 up. Or let's go have a slope of 2, 6, 10. Slope of 2. Just for later so that I can, when I do some testing about the line, I can figure out what the values should be. And then we could test that client. We've already tested that client, so I don't need to do anything to test that. I can't test the line yet, but I can at least create it. Let's just call it line 1 equals new line. And it wants 2 points, so P1, comma, P2. 2-point objects. So if I just put the point in here, 5, 8, now that is nothing. It's not going to like that because it wants point objects, which I've just defined here as P1 and P2. And then, we can tell that it's we don't have an error because it's not showing any syntax error. So that means that, okay, everyone's getting along. Our definitions are right. We're passing the right parameters. We still don't quite know if it's working. Same thing when I print this out, I still won't know. But what I will know is that I created a line object and it's stored in the computer somewhere. So what we might do is we might think about, okay, what if I wanted to have getters? So I would want to get the points back out. And those are in my code. So actually 2 constructors, one that accepts, let's do the getters first. So I know I have setters here. I'm going to put those in the other order. It makes more sense to write your getters first so that you can check if it's working. So we're going to do a getter first. So the getters, and I'll worry about the next constructor after. Public, the getters are going to return, in this case, the points. Point, public, static, void. So get P1 will be the first one, and we just want it to return P1. So, getters and setters are usually pretty easy methods to write. Let's just say, getters for each of the point. Again, point is usually capitalized because it's an object. Fields. So one of the getters is get P1, and the other getter is the same thing, but we're not getting P1, we're getting P2. And so usually I would, now I have errors because I've got that same name twice without different parameters. If I had different parameters, it would be fine. And then, I usually don't put space between them because they're really the same method. It's just there's 2 of them. And I could do that for all the getters. So if I had, we could have a bunch of different fields in this object. We could have the name, the student ID, what classes you're taking, your teachers, what kind of car you drive, if that were like a student class. And then, you could imagine a constructor, let's say it's a student file at the college, you'd need at least their name. And maybe the name, and then it would generate a student ID. And then maybe, another field would be the address. So a constructor could have the name and the address, etc. And so you could imagine a bunch of different constructors with different information. Okay, but you'd have to have a minimum amount of information, which would be sort of their name. Okay, so we'll go back to the client. And so now how could I test that? I would do line1 dot get P1, but so that's going to return that point. But then, so that's a point. But I want to print it. So to print it, I'm going to go to string, and that method is of the point. That's this line1 dot get P1 is a point, and then we're putting it to string. So this will print out the code that we wrote for that to string method that we did before. And then we're going to do a second one here, but we're going to get point 2. And so, again, your client is not, there's not a ton of logic going on here. We're just testing, and you can see right there, that's fine. That's actually fine. Maybe I want an ampersand between them. I could actually do it all on one line. I don't know. Yeah, let's grab this one out of here. Cut. Let's add to this like an ampersand, maybe with a space before and after it, and then add in and paste that guy in. And maybe we'll, that's a print statement, so I'll just make that a print line statement. There we go. Those are my 2 points, 5.8 and 6.10. My getters are done. We could now do our setters. And again, they're going to be very similar, right? So we're going to come down here and say, setters for each of the point fields. So public, it's not returning anything, so it's void. There's no static in this class because this is creating the methods that are going to be called from static methods over in the client. Public void set p1, and then this is going to accept a point object. Let's just call it p. And then what we're doing is we're saying, ooh. So this is tricky because it's a little bit tricky. And what I'm debating is yeah, I mean, we'll test it and see what happens. My first inclination is just to say P1 equals P. And I think this is how you have to do it. What I'm a little worried about is back in the client, if we then change P, whatever the parameter is that got sent here, is it going to change the P1? I don't think it will, but we'll have to check that. Again, because the names here are pointers and they point to the location in memory of the object. So here we're going to do set P2. It's a point, and we're going to say P2 equals P. And I think I'll probably have to check this in the next video, but let's jump back to the client. I feel like this is time to end this video, but we'll jump back to the client and we'll do, I want to call a setter, so we'll go line dot, let's make a new point P3 equals new point, and let's put it at 10 and 10. Well, 10 and 5. And then we would go, let's change P2. So we'll do line dot set P2, and we'll send it P3. That's a little confusing, but especially the way that capitalization and the lowercase work. After the word set, we're capitalizing the P. And I called it line 1. So it's line 1 dot set P2. And then let's copy this code here. This is just going to show me that it worked. I'm going to come back in the next video and worry about what happens if we change P3. Maybe we do it right here. So it does change it to 10.5. If I do like a P3 dot set X, and I change X to say, let's see, it was 10. Let's change it to 20. What happens to my line? What I want to see is, did my line change? Ideally, I wouldn't want it to change because I didn't change anything in the line, but I think, yeah. So it changed because I changed P3, and P3 is the same pointer over here in the line object for P. So that logic is probably not very good. And what it might mean is that we might change these setters to actually set the fields of P1 equal to the fields of P. So we would do P1 dot set X, and we would put here P dot get X, no, P1, excuse me, P1 dot set Y, and it's going to be P dot get Y. So we're going to get the coordinates out of this point and set the coordinates in our other point before we put them in the line. So, and then I have to do that for both. So P2 dot set X equal to P dot get X, capital X, open and close parenthesis. And you're going to have some syntax errors here because it's, you know, we're learning some new syntax usually. And it's not that it's hard, it's just you have to be careful with, well, with this kind of things, with objects especially, because they're not like primitives where if you just set it equal to something, it takes on that value. They are pointers that point to the thing in location in memory. P dot get Y. Okay, so now that I've changed my setters, when I run the code in the client, changing P3 should not change my line. And it doesn't. So that was a good thing to check. It's one of these weird things that we're not used to happening, but I kind of suspected it was going to happen. So that is a better way to handle it. I don't know how to predict something like that from your perspective. Usually, so I guess the moral of that story is if your fields are objects, so these are not primitives, these are objects, points. In the previous example, the fields were primitives, and so it doesn't matter because they're just integers. They're not. They're going to actually contain the value. But if they're objects, they point to the value. And so, if you want to change them, it's better to, when you want to set them, to set each of the fields in the objects individually and get them out of the parameter that's being passed, like we just did. Okay, I'm going to open that up so you can see it. If you need to pause it, you can. I still need to go back and build the default constructor, and then we can go on, and we did our getters and our setters. We can go on for find slope, is vertical, is horizontal, find equation, and the remaining methods. Probably toString is the next one that it's actually easier to do. So I'm going to call this video.